We will start with Sid Dahir from Leviat, Malaysia. So, Sid Dahir, he is a regional technical manager at Leviat. He is a qualified structural engineer and currently holds the position of regional technical manager at Leviat, based in Malaysia. He graduated with honors from University of Sydney in 2012 and worked as consulting engineer before entering the building materials industry with Ancon Building Products in Australia. Throughout his career, Sir has developed specialist knowledge in the design and detailing of concrete connections and reinforcement continuity systems, particularly with precast and jump from construction methods. So, we welcome you from ICI side and request you to start with your presentation. Over to you, sir.
Okay. Well, thank you very much for this opportunity to present today. Today I'll be presenting the topic of efficient handling of precast elements by use of ready-made precast concrete accessories. The content of today's presentation, I'll give a very brief introduction into precast concrete, and then I'll give some examples of two different types of categories of lifting systems or handling systems. One what I'm calling external solutions, and then cast-in solutions. And then lastly, I'll go into a brief overview of the lifting design process that is generally conducted by specialists in the industry, such as ourselves. Introduction to precast. So a precast structure is generally broken up into small little components, which is manufactured off-site into a factory or at another portion on the project site. The items or the precast elements are generally in a different orientation to when they are produced, when they're transported, and in their final position on site. So, for example, a flat plate element like a wall is generally produced and transported in the horizontal direction, but once it's on site, it is then rotated and put into place to carry vertical loads. So for these sorts of, to transport these systems or these concrete elements from the factory to the yard, we need special items to facilitate the connection and lifting of them. There are what we call handmade solutions to lift precast elements. These are sort of just typically manufactured from readily available material that's already used in construction, such as just reinforcing bar or post-tensioning cables. And they're, with the handmade solutions, they're generally designed on the spot or just sort of based on past experience. And they can lead to catastrophic failures because the items themselves or the materials themselves are generally not designed properly or taking into consideration that the full safety factors or the full forces that are needed that are actually present during the lifting stage. So the disadvantages of handmade solutions, again, they're generally fabricated and installed of typical details by the precast manufacturer. They utilize materials that are not typically designed for the forces during lifting. And the safety factors in the designs are left to the designer or to the precaster, whoever is responsible for those details. And most importantly, the precast manufacturer, if it's using sort of a typical detail that they regularly use, takes full responsibility and assumes the full risk. Right? In contrast, ready-made systems come with capacity tables or design services based on international codes with high levels of inbuilt safety in the design. Ready-made systems are also supplied with installation instructions and accessories for easy and correct installation. Okay, so there's two categories, general categories of precast handling systems. One I've called external solutions, which is generally special machinery that connect to the concrete using suction or clamping or hydraulic means. And the other category is cast-in solutions. And I'll give you some examples of those. The cast-in solutions range in terms of the availability, but in today's short presentation, I'll give sort of the four main category types, which is sort of a header type stud or a header type anchor, threaded inserts, a plate-like element or a plate anchor, or wire loops. So for the external solutions, they generally require a high volume of construction or a high volume of elements for their viability. They're good for automation of precast facilities, but they do require a medium to high level investment. where for cast-in solutions, they're suitable for all project types, and they're designed to work with standard machinery that's already present on construction sites, such as a overhead crane, or even a forklift, or depending on the type of concrete element you're looking at. And overall, they generally have a low investment cost to implement into the project. So I'll first go into some of the external solutions. I'd like to note that the products I'm about to show are not solutions from Leviat. However, I thought it's important to show the full range of possible solutions that are available in the market, just to get people more excited about precast and how things can be built better using precast systems. So for suction solutions, utilize vacuum technology to create a connection to the concrete. They're fast and efficient handling, which does not require patching of the concrete after the handling is completed. They do have a high investment cost due to the complicated machinery. However, they are ideal for automation of high volume precast yards or large scale infrastructure projects. So for example, the image you see on the left is a typical segment for a tunnel, and with infrastructure or tunnel projects are generally quite long and last over a number of years, and they have thousands of these segments. And so the investment of machinery of this type to sort of speed up the installation process can be justifiable. Another solution is clamping solutions, which are available, and they're specialized devices to suit the specific shape of the concrete element. They have, I would say, a medium level of investment because they're generally relatively small components compared to what we just saw, and they can be also attached to existing machinery. But they're best suited for handling of what we call commodity type precast items, such as road barriers or precast water pipes or pipes in general, where the shapes are fairly standard and regular and generally in high volume as well. For hydraulic solutions, tilt-top tables is quite common, particularly in Europe, where it's basically a specialized formwork solution, which is suited more for high volume precast yards and for precast elements such as wall panels. Right? They allow the panels to be poured flat, and then the formwork itself tilts and rotates, and which makes demolding a lot easier, and also storage as well, because it does allow earlier demolding time, because you're not relying on the concrete sheet capacity during lifting, so you can demold earlier. And that does increase efficiency because you can then turn over more volume in the same amount of space. It does require a decent amount of investment to introduce this into a precast yard. However, if they are suitable to, say, medium to large scale plants which are doing wall panels on a regular basis. Now, for the other category is cast-in solutions, and I'll just give you a brief example of some of the typical items that are available in the market, and also available through our company. So vertical head anchors is probably the most common type that's available. They're based on a system developed by Dr. Häusler in Germany, and they offer a quick and safe connection. So the images you see on screen, they generally consist of a double-headed steel anchor, where the larger head is what engages with the concrete to provide that physical connection, and then the smaller head is what's actually visible on the concrete surface. And that's been designed to work or to integrate with a lifting clutch, which provides a quick and safe connection. And the clutch itself, once connected and loaded, cannot actually be disconnected, right, until the load is released. They are installed using recess formers, right, so that the anchors are situated below the surface, so they can't be damaged during transportation or stacking or storage. And it also allows a quick finish, basically. So you can simply just fill the little recess with grout and provide a flush finish with minimal rework of the unit. Most importantly, they are engineered design. The capacities are calculated based on international standards, which I'll give a quick overview later in this presentation. So with spherical head anchors, they're available for across a large range of sizes from 1.3 tons to 32 tons, and can even go up to 45 tons on request. They're very quick to attach and remove, which is important for speed of installation. And a good thing with them is that all the information is visible on the head for a proper quality check before the element is lifted. So the information on the head is the load class, and then the manufacturer as well as the length. Because with each load class, they're available in multiple lengths to engage more of the concrete to be able to offer higher capacities. And so all that information is visible before the lift, so that you can compare against your lifting design to confirm that the correct anchor has been installed. Another system is the threaded lifting anchors type. There's also another cost-effective way of lifting, particularly very thin elements such as wall panels, and they typically consist of reinforcing bar with an attached ferrule with a thread on it at the end. And so having the longer reinforcing bar allows the load to be dissipated over a longer area, which is important for thin elements. And so they're available in many different sizes. What we have is from 1.2 ton to 6.3 ton. But the systems we have available utilize what's called an RD thread, which is more of a rounded thread, which allows sort of a bit of gap in between the male and female components, so that if any debris or concrete slurry does get into the thread, it can still, there is that tolerance there, so the thread can still be installed without reducing the thread length, and so full safety can be maintained. So the casting inserts are generally connected with either a sort of a connecting loop or even a specialized clutch, depending on the preference and depending on the amount of reuse that they want to get out of this. The next system is the plate anchor types. These work quite similar to the spherical head systems, but it just comes down to preference by the end user. These are typically used for thin-walled elements, particularly for direct lift. So they're quite common in Europe in combination with the tilt-up panels. Sorry, not the tilt-up panels, the tilting tables construction. So once the elements are rotated, they're then lifted and maneuvered around using these plate anchors. But they can also be used for edge lifting, as you see on the bottom right here, where if a tilt table is not being used, you can still rotate the panel using these anchors. But we generally recommend additional reinforcement to strengthen that concrete edge and reduce the age of concrete that's needed before lift can occur. And the last type I'll present today is the wire lifting loops. So again, these are safe and reliable and more importantly, fully engineered. They're designed with inbuilt safety factors, and they generally come with sort of pre-coating or indicators to make it clear at what level of embedment they need to be installed to ensure that you get the full engagement of concrete. With lifting loops, they're generally they're designed to protrude from the top surface of the element, and so they're typically more suited for sort of semi-precast beams or beam girders for large infrastructure projects, where an additional topping layer is going to be poured on top, and so you don't need to cut away the loop, right? So because it will then be buried in the topping layer. For most sizes, no specialist lifting clutches or equipment is required, or any particular recess formers, so they're quite easy to install, and they can be used with standard lifting hooks or shackles. Now, I'll go into a bit of the lifting design process, also according to the European approach. And the reason I'm doing this is just to give a more of a overview of what's actually involved in proper lifting design and how that compares to sort of handmade solutions where things are sort of just done by feel, basically, and just to highlight all the additional impacts that can, or the additional factors that can occur during the lifting design. or the lifting stage. So overall, there's 7 basic steps when preparing for a lifting design process. I'll go through them one by one. Okay, so the first step is to determine the number of lifting points required for stability. And this generally depends on the shape of the precast element. There's the three most common types, I would say, beam elements, a plate-like element, and a column element. So a plate-like element is what I've mentioned before, where it's basically a wall panel, but during the lifting process, it's been treated as a plate because it's been lifted horizontally in most instances. And a beam and column element are essentially the same. They're both rectangular sections. However, a beam element would be poured and installed in the same orientation, whereas a column would most likely be poured flat and then rotated and then installed on site. So that they do vary a little bit. Now, for a beam element, generally 2 lifting points is sufficient if they can withstand the load. Whereas for plates, unless it's an unusual shape, you can probably go down to 3, but it's not recommended. We generally recommend at least 4 types, mainly for the most common types of wall panels. And for column elements, you can get away with 1 lifting point if the load is quite small, and there's still plenty of redundancy in the design. However, at least 2 fixing points is recommended. Now, the next step is to calculate the concrete weight. This is probably the easiest step for standard geometries. It's simply just the volume times the density of concrete, and we typically utilize 2,500 kilograms per meter cubed for reinforced concrete to take into consideration the weight of the steel as well. The third step is to define the optimal rigging system. Right, and so the main functions of correct rigging systems is to ensure equalized loading between lifting points and also to ensure stability. And it can be thought of as sort of when you're lifting particularly a plate-like element, which is the most difficult, right, is to think of it as just a table upside down. We all know that the best table is when the lines of support or the points of support are located sort of the furthest towards the edge and equal distance from the center of gravity. If you have your points of support located close to the center or off center, it's clearly unstable or not desired. Now, we also need to take into consideration that the rigging system distributes the loads equally to the lifting points. So when you have a spreader beam with two anchors or 2 connections, it's quite straightforward. However, when you do have a plate-like element with 4 anchor points, we do recommend the use of a load equalizing triangle, which allows minor rotations to be able to adjust for any minor deviations in the lengths of the chains. So, for example, these are some examples where the rigging system does not distribute the loads equally. And so if you just have all chains connected to the same point, generally the shortest chain will take all the loads because there's no ability for that rigging system to distribute or rotate or distribute those loads to the other chains. So you can see automatically that your load is doubled than what was designed for. So it is important to look into proper rigging systems when doing this, or including these sorts of possibilities in the design process. What else you can see here is when a spreader beam is used, but still with no load equalizing triangle, again the shorter chains would only take the loads, and the effective load will be doubled onto the anchor.
Yeah, Sid, sorry to disturb. You need to wrap up the presentation. We have audience Q&A also now.
Okay. All right. I'll just have another minute if that's okay. So the first thing is for calculating the static load of the lifting point. This is simply just dividing the weight of the element per anchor and taking into consideration the sling factor. So depending on the angle of the chains, you do have load amplification. And that needs to be taken into consideration because you can see it can increase the load by up to double just due to the angle of the connection. And then also when you're calculating your tension loads or your design loads, you do need to take into consideration the two cases, demolding and lifting and handling. So during demolding, you do have additional suction forces and friction forces during the demolding stage, where during lifting and handling, you have what's called a dynamic factor or a dynamic coefficient. And that takes into consideration any sort of vibrations of the crane, or if it's a moving crane or a moving tractor that's holding a precast element, that can have a lot of impact loading on there. That needs to be taken into consideration. So a quick guide. So yeah, the suction factor for rough sort of molds can go up to 3 kPa as a guide. And also for the dynamic factor, when you're moving through rough terrain, it can create a 3 to 4 times load increase per anchor, which generally needs to be taken into consideration. I'll have this as my last slide. So when you're selecting the required inserts, there's two types of designs that you have to, or failure modes. So the still failure mode and the concrete failure mode. So for the still failure mode, when you're using a proprietary system, according to the European requirements, it comes already inbuilt with a safety factor of 3. So our 10-ton anchor is actually designed for 30 tons. But that's already inbuilt. That doesn't need to be taken into consideration. And when you're doing the concrete designs, depending on the failure modes, but there's many that needs to be checked per actual lift. But a safety factor of 2.5 is normally used. But it's important to note that you have to use the concrete strength at the time of lift, not the 28-day strength, because typically concrete elements are handled, 2-3 days, or even after concrete pour. So you're not getting that full concrete capacity, and so that's an important thing to highlight. One more thing is that when you're looking at plate-like elements, particularly, they're generally not designed to carry their self-weight because they're designed for vertical elements. And so an additional check needs to be taken to ensure that the element itself is not going to crack during transportation due to the weight due to its self-weight. Sorry, I apologize. I rushed a little bit towards the end.
Yeah, no, not an issue. So we will take audience question answers. So any questions from the audience, you can raise the hand. The person will come with the mic. Yeah. So, yeah, it is there. Just a moment. Yes.
Hello, yeah, this is Bosle. I'm from BG Sirke. My question is, when we are lifting this wall component, which has been casted horizontally and we are been tilting with tilting station, the angle of tilting station normally comes between 70 to 85 degree. In that case, when we are lifting this component by the EOT crane mounted on in the shed, there is a inclination while lifting. There is a two-way movement. One is towards the lifting upper side and another is leaving the component from the pallet. So there are two forces acting. One is in inclined direction as well as another one is away from that component. In that case, the trolley, that is the trolley of EOT, has the tendency to move away from the component and it gives the jerks. So how you normally tackle this issue?
It's hard to visualize what you just asked for, but typically with the you're referring to a tilting table, I assume, that it doesn't go fully vertical. So typically the anchors themselves are still designed for an allowance of some sort of vertical, so some inclined load. So it can go up to around 10 degrees inclined still, so that it can be lifted, and there will be some sort of load going towards the edge of the concrete. However, it is much lower than doing a fully vertical load, right? So a proper lift from flat to vertical. So it does help. The tilting table does help alleviate that. Again, we're not experts in tilting tables ourselves. What I just showed, what's available there. But I think this might need a bit more of a discussion, as I'm not fully sure of what the issue you're referring to. However, I believe we do have a booth at this conference. You're welcome to sort of visit the booth and give us your details. and we'd be more happy to do more detailed discussions with this one.
Thank you.
So thank you, Sid, for being there with us. We would let you know the audience question, if any, later on. Yeah,
Okay.
see you.
Thank you very much for the
Thank you.
opportunity. Bye.
Yeah, thank you. Thank you very much. Now we have a small video from one of our silver sponsor, Alpen. I'll request team to play the video, 5-minute video from Alpen team.
Good afternoon, everyone. It's nice to see you all in a face-to-face mode. I would like to present short videos, which would be fair enough to make a justice to Allplan software. Just to tell about myself, I'm Gyasuddin Siddiqui, representing Allplan in India. And we are also having offerings such as Allplan Bridge, Architecture, Allplan AEC, and nevertheless, Allplan Precast. So I think so we can go ahead with the
We are Allplan Precast, Allplan's global competence center for prefabrication. As our Design to Build motto suggests, we support you along the whole precast process, from the first cost estimate to the precast parts design and detailing, right up to generating accurate production data. With the model-based calculations within the Sales Manager, you have the tools you need to quickly and securely develop impressive bids. This sophisticated 3D model calculates volumes and quantities automatically from the building model, generating lists and graphical reports, and transferring data to a commercial bid preparation program. PlanBar offers an ideal and unique synthesis of model and drawing-oriented work. With PlanBar, it is up to you whether to work on a 2D drawing or a 3D model basis, because all drawings and views are 100% consistent with the model in any second. Our precast design tools in PlanBar support you with precast design and detailing of any complexity and for any precast type. Numerous automated functions and integrated quality assurance enable optimum precast processes. We support the work preparation and BIM management processes with TIM, which prepares the data for production so that the production process runs smoothly. With TIM, you can generate reports such as production and billing data easily and quickly. The Delivery Manager module enables you to simulate the stacking of your elements in 3D. Plan your virtual transport racks directly from the 3D model or the list of elements. For swift assembly, simulate the production and delivery process in TIM, thereby ensuring increased efficiency on the building site. Our mobile solution, MTIM, also supports you in the factory and on the building site with valuable and up-to-date information about the building project. Do you want to know where a delivered element is situated in the building model? Simply scan the barcode of the element and MTIM will immediately show you its position within the model. Visit our website to get more information about our high-performance software solutions and services for the precast industry. The design and detailing of precast parts consists of a lot of detailed work and can therefore be time-consuming and error-prone without a solution like PlanBar. Allplan's smart design and detailing solution for precast parts maximizes your productivity with ease. Precise 2D plans and clear 3D models are created with just a few clicks. This is because automated workflows enable highly efficient and reliable planning. Structural precast elements can be modeled with PlanBar both freely and parametrically. Walls and slabs are quickly imported, analyzed, and planned. PlanBar automatically takes care of the intelligent division into producible and deliverable units. The software also calculates the basic reinforcement independently and safely with its unique one-click reinforcement feature. Our revolutionary technology also creates fully automated descriptive shop drawings, entirely according to your specifications and for the specific requirements of the respective production step. All plans in PlanBar are also 100% consistent with the model at all times and therefore reliable. At the same time, the software seamlessly supports all common precast concrete formats and correctly controls all production machines. Thanks to the linking of reinforcement, concrete and fixture geometry, PlanBar calculates the weight and exact centers of gravity of all precast elements while still in the planning phase, thus safeguarding subsequent truck and crane work. PlanBar's connection to BIM Plus also enables efficient and always up-to-date collaboration between all project participants. With unique automated and smart workflows, PlanBar takes your precast design and detailing to a new level of precision and efficiency. Choose one of the world's leading precast BIM solutions. Choose PlanBar.
We will continue our story with the family garage. The house is almost ready and the family is eager to move their cars into the garage, so it needs to be built as fast as possible. Therefore, the family opts for prefabrication. This is where PlanBar, Allplan's precast detailing solution, comes into play. PlanBar is an independent product, but uses Allplan as its technical basis. So, for Allplan users, the user experience will be very familiar. The software enables you to manage all your precast projects with the utmost efficiency and precision. PlanBar has dedicated modules that convert any 3D architectural model from Allplan or other CAD software into precast elements. Let's take this prefabricated staircase, for example. Technology such as Python parts allows the easy conversion of a classic staircase into a precast one by introducing specific supports and also adding parametric reinforcement. Using the Precast Elements module, we can convert any 3D object into a precast element. Detailing the element is one click away. We will use PlanBar's unique element plan tool to generate automatic formwork drawings, fixture positionings, and reinforcement plans with bar bending schedules. What about walls and slabs? Does PlanBar offer a smart solution for optimizing the detailing and production of walls and slabs that are produced in highly automated manufacturing environments? The precast slab and precast wall tools are the perfect solution for this situation. Both start with choosing where to position the crane, just like reality. We will choose a crane positioning point. The software will display the available lifting capacity as determined by the crane leverage arm. The software enables the definitions of multiple types of slabs. By choosing the desired design parameters, the software will divide, chamfer, place the transport fixtures and reinforce the slab automatically, while still giving you the possibility of making manual changes for the final optimal solution. The same approach is used for the walls. As you can see, all requirements regarding element division, concrete cover, and even reinforcement are taken into consideration. The result is a conversion of a large concrete wall into several precast walls that can be produced and assembled on site according to contractors' possibilities. 3D precast element creation is easy, but what about the detailing? Is there a fast way to generate the detailed drawings? BIM Booster is the answer. This module allows you to generate the unique elements with automatic detailing. This way, you will always know how many unique elements need detailing and, at the same time, it allows multiple users to access and edit this information in real time. The automatic drawings can be modified, elements reinforced and fixtures inserted even after the drawings are generated with BIM Booster. Thanks to the check plausibility and synchronize model and detail tools, your global model is always up to date. Changes regarding formwork, fixtures and reinforcement can be transferred from global model to detailed drawings. The other way around is also possible. Modifications from detailed drawings can be transferred to the 3D global model. If you need to design and detail complex sandwich walls or multi-layered elements, there is a tool specifically for dealing with such elements. IFC Assistant enables you to group multiple materials to form a single precast element with a unique mark and obtain a high-quality production drawing. The MEP Wizard is an open BIM feature and enables you to convert your MEP objects into plan bar data. Simply align the imported objects with the available items in your MEP library. The tool will generate the required openings according to the fixture's requirement in order to avoid clashes with the structural elements. At any time, you can generate a legend or a report with the precast elements used in your current project. The advantage here is being able to get multiple quantities, such as number of precast elements, volume and mass for each unique precast element mark. All this BIM data can be exported for production use with Allplan's work preparation and BIM management solution TIM. TIM's smart features ensure that the factory receives all the required information for production to the quality standard required. PlanBar is Allplan's unique BIM solution specifically for precast projects. PlanBar takes your precast design and detailing processes to a new level of efficiency and precision. Design walls, slabs, and structural precast elements such as stairs faster and more accurately than ever before. Access our website for more details. We also offer personal demonstrations, so you can see the benefits for your projects firsthand.
So these videos are also available with the ICI Pune chapter. So if anyone is interested to have a closer look at it, can always approach Suchita. And if you require any more support, can visit our website or contact me. Thank you so much.